My name is Joe, and I'm a research professor emeritus at the Desert Research Institute. For the last 27 years, I've been uh, trying to build and maintain an ice core lab, a unique ice core lab there. And we're sitting right now in the French Alps. Chamonix is in the valley below us, and that is Mont Blanc behind us, one of the highest peaks in Europe. So our French and German colleagues, collected ice cores from the Col du Dôme and the Dôme de Goûter, just on the other side. And they collected that core in 1999. We analyzed it about 3 years ago in our lab in Reno. And we were quite surprised to find that the record, it's only 40 meters long, so 130, 140 feet long, and it extends all the way back into the end of the last ice age. That record extends from that period, not only the ice age, but also this period when there were hardly any humans, and they were hunter-gatherers, all the way up to through the Industrial Revolution, through the Roman period, and in the Middle Ages, and the Black Death, and all these huge events in history that we know about, all the way to 1999. So one of our goals while we were here was to collect a newer ice, more recent snow and ice from the Dôme de Goûter, where this 12 to 14,000 year record came from. So we were up there in a helicopter about 4 or 5 days ago, collecting a core in about 50 kilometer or 30 knot wind roughly, blowing snow everywhere at 14,000 feet. It's quite an adventure to fly up there in a helicopter up 10,000 feet, get dropped off for 3 or 4 hours, and then picked up and come back down. It was a pretty exciting event. An overriding theme of our lab for the last 25, 27 years has been to develop ice core records with enough temporal and spatial resolution and a broad enough spectrum of elements, the appropriate elements, to allow us to contribute data sets or provide information to many different fields of study, not just climate science or not just ice core science or whatever. And that's people like ancient historians, archaeologists, economic historians, volcanologists, and even recently epidemiology. So trying to bring this into human health, use our ice core records to assess things like cognitive decline during the Roman era from exposure to atmospheric lead pollution. So these aerosols we've been talking about are these tiny little droplets and particles, very, very small, in the air all around us. And the ones that we measure in Greenland, many of these aerosols that we measure in Greenland, for instance, the lead pollution, come from mid and low latitude emissions. So they're not emitted in the high latitudes in the Arctic regions. They're emitted in the mid latitudes where most people live, or in the low latitudes. And so you can imagine the sensitivity of the record in Greenland is quite small, even though it's adequate for a lot of things. It's quite small. We'd like to be closer to the source of those emissions. So here we are in the center of Europe, effectively in the cradle of Western civilization, near the cradle of Western civilization. And so that's why we'd like to, the record that from here is particularly important because it is so close to those emissions. So one of the main reasons we want to be here collecting a core is because we get a record from within Europe instead of a record from way up in Greenland, 4,000 or 5,000 kilometers away.